Hi, this is Lester Martin from Starburst Academy, and I want to present a series of videos here focused on a workshop that I have coming up. So it's a bit of a dry run recording for me and check the timings, but as much as anything else, I'm going to let it out for some folks to maybe take a look and do some beta testing and try the labs for themselves. So let's just jump on in. When I have this field event, I'll kick off with a header slide, of course, and then I'll quickly go into what I believe is always important, especially in a face-to-face event that this will be. A little connection before content, a lot of good information about me there, or at least my technical professional career there. And at the top there is a quick About Me link that I welcome you to click on or type in and find more about me if there's some interest as well. Glad to connect with just about anybody. All right, so these objectives. Number one objective is to have only a few slides. So I have probably a handful of slides we'll glance at here. What are we going to do? A quick, brief introduction of both DBT Cloud and Starburst Galaxy. We'll quickly follow that and just make sure we agree on a reference architecture to build our data pipeline within. We'll present that pipeline use case, single slide, talking about it, and then absolutely we'll make a video for each one of the 7 labs that you see listed below. So what's DBT in a slide? Well, screenshotted something off their website, but it is a workflow system. It's a workflow system that works with all kinds of SQL-based technologies, databases, data lake systems, etc. And it brings the concepts that software developers have: continuous integration, continuous development, definitely version control, all that good stuff together, so we can build these pipelines, maintain them, and promote them to production, and so on and so forth. So we focus on using DBT Cloud, their SaaS offering. And what's Starburst Galaxy? Well, Starburst Galaxy is another SaaS offering. It's from Starburst. That's where I work, so a little slanted here today. And Starburst itself, Galaxy, and another platform called Starburst Enterprise, they're built on top of open source Trino, a extremely multi-parallel processing SQL engine that can connect to a ton of different resources. In fact, that's one of his strengths. And then, of course, people in the front end using their tools or their applications can interact via Starburst to get to use it as a data access layer to a variety of different technologies. Again, links to both these at the top. In the chat, in the session down at the bottom, in the video notes, I'll make sure I provide a link to a blog post that'll reference all these, and from there you can get this PDF that has those links if you don't want to just type them in. Well, the reference architecture that we'll be using is a pretty well established one out there, using zones to demark the kind of quality and purpose of data at various levels. And across the top, where you see in the bold words of land, structure, and consume, those are the words that we use here at Starburst. But below that, you see some other terms that maybe other people use as well. But we're all talking about the same thing: land, structure, and consume. And if we think about that architecture, maybe just a little builder slide here for you. Think about that lake house there in the center, and what are we doing? We're going to get data from a variety of places, apps and whatever, and we're going to bring that data as is, hang on to it. Why? Because we might realize the things that we do as we transform them and enrich it and all that and normalize it may be wrong tomorrow. We may have messed up today, maybe laws or regulations or contracts change it and that kind of stuff, and keeping that raw data is going to be critically important to us. But we do want to drive it to restructure it in our pipeline to be in such a way that we can count on this data. This is like the definite statement of fact and the models and all that good stuff. And then, of course, We do want to have all this. Why? Because we're trying to drive data analytics and data science. So we may often realize that there are questions that people ask that aren't as simple as, yeah, show me the customer, show me the orders. And they are richer SQL questions that we could roll up together and put together possibly a materialized table or materialized view even, if not just a simple view, to present a consume layer. A consume layer is going to be those reporting-based queries that, applications and often dashboards and BI tools themselves are accessing on a regular basis. So that's how data is going to go through that architecture from land to consume and where everyone's involved. Now, there's a ton of different technologies across our vast industry that you could use for all of that. I'm going to focus on just some technologies that we're going to use today here in the workshop. So icon at the top says, let's use an Amazon S3 to emulate to be our data lake persistence layer. Our data sources are going to just make assumption that we have a custom app out there producing some data. And then we're not sure how it got there, but there's some data in a Postgres database. For our intent and purposes, we just assume someone else has loaded that. Now, the ingestion per se is not something that either Starburst Galaxy or dbt Cloud see as their strongest suit, but they both have mechanisms to kind of account for this. So I put some icons of some possible ingestion tools on the left there, NiFi, Airbyte, and just maybe some custom scripting those things. But as we land the data and it comes from a raw in our situation, that data is kind of come in. Yeah, there's Postgres, but there's going to be some data that's just simple comma-separated value files. So we're going to have that. And because of that, we'll leverage the Hive table format. It's pretty universal, pretty easy to access to wrap a table around information in that kind of format. Now we want to move that data via some rules and some guidelines after we figure out how valid the data is, etc. We want to build some models, as they're called in dbt, and those models will be written in SQL. So we're actually going to write models that dbt will send SQL statements off to Starburst Galaxy, and then that will ultimately create our structure layer, our very finite, well-established, standard names, high quality data, etc. structure layer. And because of that, we're going to transition and use an iceberg table format, and underneath that, the Parquet file format itself. This structure layer is also a great place for all kinds of applications, including web-based notebooks for different kinds of analytics and so on and so forth. We won't focus on that in our labs. We will build a further model once we get some business requirements we'll just keep it simple. In our case, one business use case or one scenario. So we'll end up establishing a query that'll satisfy that, and then we'll bring that query back into dbt as yet another model. And because of these models and do it in dbt, we'll actually get to see a really nice lineage graph, or DAG sometimes they're called, that shows, hey, where did that consume data structure come from? It came from the structure. Where the structure came from? It came from the land. So I'm looking forward to letting you see that. And of course, we'll keep those in Apache Iceberg using Parquet. And then the little purple text at the top will actually go ahead and in Starburst Galaxy promote that information into data products that you'll see in our second to last lab. Lastly, we want those engines, in our case, or those tools. In our case, we'll just keep it right in Starburst Galaxy as a little bit of a query runner, a query editor, so we'll keep it focused there instead of using some high-end BI tool. But more appropriately there in the middle, we'll be consuming it from accessing directly to Starburst powered by Trino. All right, I think we're at the second to last slide, or really the last slide. The scenario, we'll be using dbt's Jaffle shop, their little reference implementation there. If you don't know what a Jaffle is, I think you'll find out later in my slides in the lab, to sneak it in there, or invite you to go look it up. But basically, we'll have some landing zone data sets. Some of them will already exist, as I mentioned in Postgres, some customers and orders information. We'll grab that. We'll also have some information already loaded out in Amazon. We'll do some look at all those data sets, look at some validate them. We'll focus on standardizing those data sets to build us representations of those same three primary entities there: customers, orders, and payments. We'll load that up in Iceberg, as we mentioned. And then we're going to go ahead and implement that business requirement, and we'll offer that up as a view in our consume zone. We'll see that it's a pretty long 20, 30, 40, 50 line kind of a query, joining and aggregating all kinds of good stuff. That'll be our consume zone model. We'll see both in DBT Cloud and in Starburst Galaxy. We'll verify that land structure consume lineage is there, it's appropriate, it's visible and understandable. And then almost last, but one of the last things we'll do in Galaxy would be we'll then curate that data set, document it, promote it, ultimately as what we call a data product, and see what that looks like from data consumers. Then we'll wrap up and version our code and commit it and create production environment, so on and so forth. So in all fairness, what should we do? We should do some labs. So I'm going to do these labs and follow on YouTube videos here in a second. Here's the lab list, and in that YouTube video, look for a link down the bottom to back to my blog, and that blog will give you this. This will be a PDF that I'll output. It's in a Google Doc right now that I'll work through on the side, and I even put in there, so I don't have to publish these slides you're looking at. I published the key slides as you see here, and just gave you the end of the builders and not all the noise and that kind of stuff. And then the rest of it is just lab 1 through lab 7. All right, let's get going.